Is that mine or yours?
That's yours.
Thank you.
Yeah.
What numbers did we do, kids? 12 through what?
44.
44. Okay. Number 12 is a squared plus 20a plus 100. 14 is h squared plus 14h plus 49. 16 is 64 minus 16m plus m squared. If you wrote it in descending order, that's probably better. Number 18 is 4b squared plus 12b plus 9. 20 is 64h squared minus 64hn plus 16n squared. 22 is u squared minus 9. 24 is 4 minus x squared. 26 is 4q squared minus 25r squared. 28 is 25y squared plus 70y plus 49. 30 is 100x squared minus 4. 32 is a squared plus 8ab plus 16b squared. 34, is 4c squared minus 36cd plus 81d squared. 36 is 36y squared minus 169. 38 is 25x squared minus 10x squared y squared plus y to the fourth. 40 is 9/16 k squared plus 12k plus 64. 42 is 49 z to the fourth minus 25 y to the fourth. And 44 is r to the fourth minus 29 r squared plus 100. What questions do we have? 26. Okay. What kind of special product is this? What is special about this one?
It's the same, just it's plus 9.
Right? So what happens with those?
You don't have to do the beginning and the last.
First and last, that's right. So all we have to do is the first times first, last times last. So what is 2q times 2q? 4q squared. And then it was, what is 5r times negative 5r? Negative, right? 25, and then r squared. What else?
20.
Okay. H minus 4 in quantity squared. So what do we do? Okay. I do think I know what you're saying. Now what?
Double rainbow. No,
We distribute.
double.
What's 8h times 8h? 64h squared. What's 8h times negative 4n? And then what's negative 4n times 8h? And then what's negative 4n times negative 4n? Positive. Negative times negative is positive 16n squared. Now what? Like terms, where are they? No, they're both negative 32. Negative 64hn plus 16n squared. What? What else?
What was number 30 again?
30 was 100x squared minus 4. What else? We just did 20.
I did something really weird. It looked different.
Did we do 14?
Yeah. Number 14. H plus 7 quantity squared. What do we do? Mm-hmm. What's h times h? H squared. That's true. What's h times 7? 7 times h. 7 times 7. I like terms. So, why did you ask about that? I'm confused. Why did you ask about this one?
I thought we had to do descending order.
The what?
I think I got confused because I thought we had to do descending order.
That is descending order.
I thought descending order was
H.
the biggest and smallest.
H squared, no h to the first, no h.
I thought of, was thinking of the, before number.
What?
I was thinking of the before numbers.
You were thinking of the coefficient?
Yeah.
All right. Any other things on this one? Let's hit 8-5. And learn how to factor by grouping. They call it using the distributive property. We are factoring by grouping is what we are doing. So, everything we've done thus far has been, well, in the last couple lessons, we have used the distributive property to turn products into a series of sums. We're now starting to learn how to go the other way around and turn the sums back into products. So we're starting at the end of where we were and going back to the beginning. We're learning how to factor. Okay? We're going to start by learning what a GCF is.
Sorry, what'd you say this lesson's called?
They call it using the distributive property, but I would call it factoring by grouping
Okay.
if I was naming it. So, GCF stands for greatest common factor. So, if we are looking at 15W minus 3V, we are going to factor that using the greatest common factor. So what we need to do is we need to figure out what is the common factors between this term and this term, starting with the numbers. So what is a common factor to 15 and 3?
5.
What goes into both? 3 goes into both. 3, this is prime, so it's only 3, right? So if 3 doesn't go into this, then it doesn't have any numbers in common, right? So we're going to pull out a 3. Then we need to look at the letters. Are there any letters in common between those two? No. So we're only going to pull out a 3. Now, when we pull out a 3, when we factor it out, we have to write down what's left. And what we mean by that is we're dividing each one of these things by the common factor. So we're doing 15W divided by 3. So what is 15W divided by 3? 5W. When we factor 3 out of the second one, what's left? Just minus V, right? Which is not nothing, but it is, in fact, something. You don't have to be sorry, bro. Calm down. Okay, let's do another one. 7U squared. T squared. Plus 21UT squared. Minus UT. Okay, so we're going to figure out what the greatest common factor between these three terms is. So we start with the numbers. Is there a number that goes into 7, 21, and -1? No, because of the 1, right? Right? If it was just 7 and 21, we could take a 7 out. But because of the 1, we can't take any numbers out. So now, what letters are in common? All of them have at least one U and at least one T, right? So that's what we're pulling out. When we pull a UT out of this one, what is left? 7UT. Because there's 2 U's and there's 2 T's, right? So we pull 1 out, 1 left of each. What about this one? We pull a UT out of this one, what's left? 21T. Because we pulled the U out and 1 of those T's out. When we pull a UT out of this, what's left? 1. Minus 1. I'll say we're turning a list of sums into a product, right? Factoring is turning sums into products. Distributing is turning products into sums, right? So let's learn the fact that now we know how to factor by grouping to get it even more, get some things even more factored by factoring by grouping. When you do a factoring problem, even in the next lessons when we do trinomials and all these other things, you always, pretty much, want to look to see if there's a GCF first. Because if there is, it's going to make your numbers smaller. And we like dealing with smaller numbers when we're trying to factor. So the instructions say factor. And the problem is Rn plus 5n minus R minus 5. Okay, so how many terms are in this problem? 4. There's 4 terms. 1, 2, 3, 4, right? 4 terms. So when you see a problem that has 4 terms and the instructions say factor, you're almost certainly going to factor by grouping. Okay? So the first thing you do is group things. Wow. You're going to group the first half and the second half. Now sometimes in Algebra 1 this happens less often and wouldn't happen on tests, but sometimes you'll have to rearrange the terms a little bit in order to get the right thing in the right place. And we'll see we'll see how to know whether you needed to have done that in a minute. Okay? So what do you notice about the signs on the first term and the second term? They're different. And not only are they different, they're exactly opposite, right? This is plus plus, this is minus minus, right? Okay, so the first thing we're going to do is we're going to divide this into 2 chunks. So we're going to put a little dotted line down the middle. Now, if we're looking at the first chunk, what is the GCF between those 2 terms? N. So we're going to pull an N out of this first chunk. We pull an N out of this first one, what's left? R. And when we pull an N out of this one, what's left? 5. So plus 5. Now, going back to where I started, the signs are exactly opposite. So if we want something to match in a minute, we're going to need to pull a negative out of this one. Is there anything that's in common between these 2? No, there's not a GCF, but we do need to pull a negative out. When I pull a negative out, this turns into R, right? And this turns into plus 5, right? Now, what do you notice about the 2 sets of parentheses? They're the same. If they are the same, that means you know you did everything right and it's a happy day, right? Because if they are in fact the same, how many terms are there now? This is a little bit tricky in this line. There's only 2 terms. There's only 2 of them. There's this term and there's this term. What's in common between those 2 terms? R plus 5. So what we can do now is we can factor out an R plus 5. When I factor an R plus 5 out of this one, what's left? N. When I factor an R plus 5 out of this one, what's left? Negative 1. Look at that. We did it. What? I can't understand. This one. We factored an N out, and when we factor N out of this, R is left. We factor N out of this one, 5 is left. On this, there's 2 terms. They both have R plus 5, so I factored out the R plus 5 and then wrote down what was left. When I take R plus 5 out of this, N is left. This, negative 1 is left. Good. Okay. Let's do another one. Three NP plus 15p minus 4n. Actually, you know what? I'm going to change this example because they don't really have one that says plus 4n plus 20. That way you have in your notes something that does both. All right, what do we need to do in order to factor? We've got to split it into 2 first, right? That's fine. They are all pluses. That's why I changed it. So, greatest common factor where?
On the left side, you can take out 3p.
On the left side, we can take out a 3p. In this first one, if I take a 3p out, what's left? N. On the second one, if I take a 3p out, what's left? 5. Now, the signs match, so I'm going to take out a positive this time, right? Not a negative. All right? So what's in common on the next one? 4. I'm going to take out plus 4. When I take up 4 out of this one, what's left? N. When I take a 4 out of this one, what's left? 5. Plus 5. Now what do I do? I take a 4 out of both of these because they both have. What? Okay. Now what am I going to do? Factor. Going to factor out an n plus 5. What's left in the first one when I factor out an n plus 5? 3p. What's left on the second one? Makes sense? Easy money? Good, 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 good. Let's do... Oh yeah, good, good, good. Let's do both of those. Nice, okay. So, let's do, actually I don't know that we need to do both of those. Let's do just this one. 3p minus 2p squared minus 18p plus 27. So what do we need to do? Split it into 2. Now what?
Left side is p.
What's left on the first one? And on the second one?
2p.
Negative 2p, right?
Yeah.
Now what do we need to do on the second one?
9.
Take out a 9. Okay. What? Excuse me. What's left on the first one?
Or 2p.
Negative 2p. What's left on the next one? 3. Now what? Well, hold on, time out. Yes, we do, but hold on, time out. Do they match?
Yeah, but like flipped.
No and also yes, right?
Also, one of them's a negative.
That's right. So, commutative property is a thing, yes? So this is the same as this rearranged. So is this the other way? So they are in fact the same, right? So let's pull out a 3 minus 2p. Or negative 2 plus 3p, either whichever way you want to say it. What's left in the first one? P. And on the second one? Plus 9. Easy money. So, zero product property says that if you have an equation and it is completely factored and equal to 0, you can set each factor equal to 0. What it actually says is a bunch of different words, but that's a lot easier way to explain what you do with it. So here we go. Let's do this example. This example says solve. We're going to do this one first. 8 b squared minus 40b equals 0. Now, something needs to begin starting now to scream in your brain. Whenever you see an equation, what is an equation? What that mean? Yeah, you got an equals. Whenever you see an equation and it has a squared in it, second degree polynomial, what should be screaming in your brain is, I'm probably going to need to factor this, because that's the easy way to solve them. So that is in fact what we're going to do. So let's factor this. We are going to pull out a b. Start with the numbers though. 8b. Pull out an 8b. We pull out an 8b out of the first one. What's left? B. We pull out a we pull a b out of the second one. I mean, an 8b out of the second one. What is left? Negative 5. Now, zero product property says that if it's completely factored, which it is, so there's no pluses in between the parentheses. The only pluses are stuck inside parentheses. That means, so it's completely factored. It's completely factored and it's equal to 0. What we can now do is we can set each factor equal to 0. So 8b equals 0 and b minus 5 equals 0. And the reason this works, in case you care, is because one of them, or both of them, has to be 0, right? Because 0 times the thing would make the 0. So that's why it works. So to solve this little guy, it's easy money, right? We just divide by 8 and end up with b equals 0. On this one, we add 5 to both sides and end up with b equals 5. So b can either equal 0 or 5. So if we put a 0 in here, 8 times 0 minus 40 times b, so negative 40b equals 0, divide by 40, and you end up with b equals 0. This works. What am I saying? No, we put a, no. I don't know why I left a 0. That's great. Yeah. If we put a 0 here and a 0 here, this 0 times this is 0, 0 minus 0 is 0, and 0 equals 0. It works. If we put a 5 in here, 5 squared is 25. What's 25 times 8? 200, right? So we've got 200, and then what is negative 40 times 5? Negative 200. 200 minus 200 is 0. So this they both work. So a quadratic can have either 2 answers, 1 answer, or 0 answers. This one has 2. And that'll always be true if you have a cubic function up there. It can have 3 answers, 2 answers, 1 answer, or 0 answers. No, it cannot have infinity. Well, it depends on how you're talking about things. It kind of can have an infinite solution of, like, it's always like any number in there, but that's a different topic for a different day. Much more likely to have no, quadratic can't really have infinite solutions. Because the parabola, no. It can't always be something. So yeah, no. 2, 1, or 0. Homework number 1. This one's going to be the small one, and the next one's going to be the long one. That's what we're doing. Because this one's easy and needs less practice. The next one is also easy but requires more practice to get good at it. Page 497, numbers 2 through 14 evens.
Number 2, only number 2. Let's go.
Okay. This is not going to be true yet, but this next topic, lesson 8.6, is a topic that you need to get to the place, it's not going to be true right away, but you need to get to the place where you can just about solve these problems in your sleep, because you're going to use this technique that much. when later on. So this is something, and this is also like balancing chemical equations or multiplication tables when you're first learning it. The only way to get better at it is to practice the heck out of it. That's really the only way to get better at this. So we are factoring trinomials where a equals 1. These ones are easy. The lesson 8, 7 ones are a little bit trickier. These ones are easy, but you've never done this before. And it requires kind of a different side of your brain. And so it's a little bit tricky. Let's do an example. The instructions say factor. And the polynomial looks like this. D squared plus 11D, factoring trinomials, plus 24. The book calls it factoring, solving x squared plus bx plus c equals 0, which is not false. But we're factoring trinomials, where a equals 1. Because the next one is also factoring trinomials, but a not is greater than 1. Okay. How many terms are there? 3. Hence the trinomials, yes? When we're factoring a trinomial, step number 1 is easy. If you don't get at least this on the test, I have no hope for you, and I am not even kidding. Because step number 1 is draw 2 sets of parentheses. Open, close, open, close. You can do that much. So there are, in these parentheses, there are 4 slots. Think foil. There are first slots and there are last slots. We need to figure out what goes in all of these slots. That's our goal. So for the first, what we start with now, the method I teach, there are multiple methods to factoring. There's box method and there's something, then there's one where you do these crisscross nonsense things and whatever else. I only teach one method and one method only. I teach guess and check. I've only ever taught another method once whenever there was one particular class that for the life of me I couldn't get them to figure out how to understand how to do it. And I taught them the box method. But I'm teaching you guess and check. What? That's probably true. All right, in the first slot, we need 2 things that multiply to get the first term. So what 2 things multiply to get d squared? D and D.
D and D what?
What? Dungeons and Dragons? No. So we put a D and a D. In the second slot, we want 2 things that multiply to get 24. So especially when you're first doing this, it can be helpful to write down the factors of 24. So how can we multiply to get 24? Well, I'll start with the really hard one. 1 times 24 is 24. What? 7 and 4, except no, it's 6 and 4, but yes.
2 and 12.
2 and 12, what else? 8 and 3. Anything else?
12 and 0.
No, that doesn't work.
24. Oh, I never had.
That's it. That's all there is. Okay. So then you pick one. So let's pick one. What'd you say?
8 and 3.
No, I'm going to pretend like you didn't say that. Let's pick a different one. 2 and 12 sounds great. So we're going to put a 2 and 12. So this is the kind of formal name for this method is guess and check. I call it the smiley face method because the next thing we're going to do is we're going to draw a smiley face. We're going to draw his nose and his mouth.
Why did you draw 3 and 3?
I don't know. That's literally neither one of those is what I meant to draw. How about a 2 and a 12? So that was the guess. Now the smiley face is the check. Okay? So we multiply along the nose. 2 times 1 is what? 2. 1 times 12 is what? 12. Okay, so what we are trying to do is we're trying to see whether or not we can add or subtract these 2 numbers to get this number, which is this middle number. Can you add or subtract 2 and 12 to get 11? No, you can't. What? It's an 11. Do you mean where does it come from? Okay, so
Oh, I see it now.
were you like, did it literally take you that long to write those things so you didn't hear where I just explained that? Because I just explained that. Okay, all right. Okay, thanks for everybody joining us. So that doesn't work. So we guessed, we checked. Now what do we need to do? Try a different set. That's right. Let's do 8 and 3 this time.
That's why he didn't do it.
Yeah.
8 times 1 is what? 8. 1 times 3 is what? 3. Can we add or subtract those to get 11?
Yes.
What do the signs need to be? Both plus. Plus and plus. We follow his nose and put a plus, and we follow his mouth and put a plus. You need to think through all the words that I'm saying. I'm not saying them just to be obnoxious. Okay? Because these will not always be ones. In the next lesson, they will be different numbers. Okay? So all of the words that I'm saying are the mental pathways your brain needs to start to think in when you do these. Eventually, you'll do these enough where you'll just be able to look at it and it's like, oh yeah, this is the answer. But not today. All right? So get in the mental pathways. Am I sure about that? Yes, I am. I know, but you're trying to fight me. Okay, let's do another one.
So that's the answer.
That was the answer.
Okay, cool.
Okay. Oh, and actually there's one more thing we should have checked, and I got distracted saying something else, but that's okay. We'll do it on this one.
The answer is D plus A.
Let's do 9 plus 10t plus t squared. So this one, in order to factor this, we need to write it in descending order. So t squared plus 10t plus 9. What is step 1?
Draw set of parentheses.
2 sets of parentheses. What goes in the first slot?
T.
T and t. Why is it t and t?
Because it goes in.
Because t times t is t squared, right? What 2 things multiply to get that one?
T and D.
Right, yeah, yes. That was not a question that time. That was a statement. I know it seems very similar. Great. Now what?
Factor 9.
Factors of 9. Great. What are they?
3.
3 and 3, 9 and 1. Which one are we going to try?
Let's try 3 and 3.
How about 9 and 1?
Okay.
Does it matter which way you place it? Could it be
Yes, it does matter, but not in this lesson. But keep that question in mind for the next lesson, because in the next lesson it is going to matter, and that's going to be part of your guess and check. So yeah, in this lesson this is always going to be 1, so it's not going to matter, but it could matter. So what do we do now? Smiley face. 9 times 1 is 9. 1 times 1 is 1. Can we add or subtract those to get that? Yes. What do the signs need to be? Plus and plus. Follow his nose, put the plus. Follow his mouth, put the plus. This is factored. Now, there is one thing that I forgot to mention that we didn't do. There's one more thing that you need to check before you circle it. Does the sign work at the end? Is positive 9 times positive 1 positive 9? Yes. So we're good. It was 5. Yeah. That's what. Let me show you one real quick. I'm going to interject an example. I'm going to interject an example. It doesn't matter. Actually, we'll do them both. What do I need? Actually, it doesn't matter. We're doing both.
Why not draw 16? Are these 2 separate ones?
These are two separate ones. Step 1, parentheses and parentheses. X times x is x squared. Now, watch this. What are the factors of 6?
2 and 3.
2 and 3, 6 and 1. What do you want to try?
6 and 1.
Let's do 2 and 3.
No, let's just.
2 times 1 is 2. 1 times 3 is 3. Can we add or subtract those to get the middle one?
Yeah.
Yes, we can. What do the signs need to be?
Positive.
Plus and plus.
It can work both ways.
But that's wrong. Why is it wrong?
Because the signs
Not
don't.
5A.
Signs don't work at the end. 2 times positive 2 times positive 3 is positive 6.
Not negative 6.
Not negative 6. This does not work. It is factorable though.
So what's the answer to that problem?
No, it's not. It can factor. There's something else. What are the other factors of 6?
1 and 6.
1 and 6. 1 times 1 is 1. 1 times 6 is 6. Can we add or subtract those numbers and get 5? What do the signs need to be?
Negative.
-1, +6.
Follow the nose, follow the mouth. Now the signs work at the end. What would be the answer to this one?
2 and 3.
Plus and plus. What would be the answer to this one? Do it. Go ahead and do it. Do it on your paper. I said you weren't going to be good enough to be able to be like, this is the answer. Huh? It's factorable. It's definitely factorable.
Oh, I know.
It's x minus 2 and x minus 3.
Because negative 2 times negative 3 is positive 6. What's the answer to this one? Did you even try? Try it.
Wait, yeah, there's only 2.
Oh, you're right. You can't factor that. Now we can. Now we do it. Try it. Try it.
X plus 1 and x minus 6.
Wow. Let's do another one. This one says solve. That's awesome. Z squared minus 3z equals 70. Instructions say solve. So, what do you think we need to do? Yes, what should be screaming is factoring. But before we factor, in order to solve, it has to be completely factored and what? Equal to 0. So what do we need to do first? Yeah, how do you do that? Subtract 70 on both sides. Z squared minus 3z minus 70 equals 0. Now what? That was loud. I accidentally screamed in my own ears because I was fixing the whiteboard. What? It's a trinomial. What's step 1? 2 sets parentheses. What's going to go in the first slot? Z and also z, because z times z is z squared. We're trying to get a 3. So we want factors of 70 that are kind of like close to the same number, right? Because 70 and 1, there's no way that's going to work, right? So what are some other factors of 70? 10 and 7, that's true. Anything else? 35 and 2? 5 and what?
5 and 14.
5 and 14. Which one do you want to try?
5 and 14.
Okay.
Everyone's like,
5 times 1 is 5. 1 times 14 is 14. Can we add or subtract those to get negative 3?
no.
We cannot. You guessed wrong. Guess again.
Let's do
10.
no.
Can't do anything.
We can do any of those.
Try to.
10 and 7. 10 times 1 is 10. 1 times 7 is 7. Can we add or subtract those to get a negative 3? And the 7 negative would give us a positive 3. So the 10's got to be negative. 7 positive. Put the negative, all of the nose, follow the mouth, and put the plus. Negative times positive is negative. That still checks out. Now it is completely factored and equal to 0. What can we do now? No. We don't have z equals some number. We just did it today. We can split it into 2. We can set each factor equal to 0. Z minus 10 equals 0. And z plus 7 equals 0. Add 10 to both sides, we end up with z equals 10. Subtract 7 from both sides, we end up with z equals negative 7. Let's go, we did it. Let's do one more. And then I'm going to give you some homework and kick you out. Sound great? Yes, good. I love it. I'm going to throw an audible and I'm going to change this example up so we can teach one more thing. Sneak in some more learning. We like that. 2x squared plus 6x minus 36 equals 0. Nah, not yet. Because I gave you a piece of advice earlier. We haven't used the piece of advice yet, so it wouldn't surprise me if you don't remember the piece of advice. We should always look for a GCF first because it's going to make our life easier. Is there a GCF between all three of those terms?
X.
2. Yeah, there's not an X because of this one, right? Definitely not. So let's pull a 2 out. We pull a 2 out of the first one, what's left? X squared. When we pull a 2 out of the second one, what's left? 3x. Pull a 2 out of the last one, what's left? Negative 18. Now, let me ask you something. How is that 2 attached to everything else? Multiplication. So how could we get rid of it? We could divide both sides by 2. What is 0 divided by 2? Still 0. So that was nice. Now, what should we do? Now we should parentheses. Now what? X times x is x squared. Now what? What? Yeah. 9 and 2, and what else? 1 and 18, and 3 and 6. What do we want to try? 3 and 6. 3 times 1 is 3. 1 times 6 is 6. Can we add or subtract those to get 3? Yes. What do the signs need to be? Minus, follow the mouth, but plus. Now what do we do? Set each factor equal to 0. X minus 3 equals 0, and x plus 6 equals 0. Up here, we subtract 6 from both sides and get x equals negative 6. Here, we would add 3, so x would equal 3. Second homework set, page 507. Numbers 12 through 36 evens. Goodbye. It's early, bruh. Hmm.